Hello, today we are going to look at the distribution of electrons in the atom for the elements from the 1st to the 36th order number. Only we will do it not for each of the elements starting from this first number and up to 36th, but we will do it selectively in order to give you an impression of how the filling of the electron configuration occurs. In addition, let us remind you today that a number of rules should be followed when filling the electronic configuration. First, the principle of Albau, principle of electron building, filling electron configurations with it. In addition, an important point is also the observance of the rules of filling each sublevel. For example, that on the S sublevel only 2 electrons, on the P maximum 6, on the D10 and so on. So let's take the very first chemical element at the beginning. It is hydrogen. Its sequence number is 1 and its electron configuration will then be 1s1. Y, D, T, K and A. The next element is helium. Its sequence number is 2 and its configuration will be 1s2. This is where the first period ends. The next element is lithium. Its sequence number is 3 and its configuration will be 1s2 and 2s1. Then sometimes, in order to make such an entry shorter, it is written as follows. We could write, here is such a record, means in front would be the same as helium, and then goes on we have 2s1. This kind of writing is called the short electron formula for an element. Next up, let's take the element nitrogen. It's number 7 and we'll show you how it's going to be. Then it would be 1C2, 2C2, next comes 2P3. Or we could write down short in front as helium and next comes 2s2 and 2p3. Next, let's write down the element neon, which closes to the second period. Its number is 10, and now then it would be 1s2, 2s2, 2p6, or it would be the short form entry looks like this, helium, and then it goes 2s2, 2p6. Let's go to the third period. The first element in the third period is sodium. Its number is 11. Its configuration would be 1s2. 2s2, 2p6 and 3s1. Or we can write down with a short formula, but now let's take advantage of the fact that ahead of it is the noble gas neon, and then the entry can be like this. Everything ahead is like neon, and the entry will be 3s1. Let's skip a few elements and let's say the element that would be silicon. Its number is 14. Its configuration would be 1s2. 2s2, 2n6, 3s2 and 3p2. Or in a short recording it will be, it turns out neon, and above neon there are 3s2, 3p2. Then let's do for the element chlorine, which has the ordinal number 17. Its configuration will then be 1s2, 2s2, 2p6, 3s2, 3p5, or in a short entry, then this entry will look like this. Everything ahead is like neon, 3s2, 3p5, and closing the third period, the element argon. It's number 18. Then the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, or in a short entry it is like neon in the front and the entry is 3s2, 3p6. So as we can see, the elements from the 1st to the 20th number, in fact to the 18th until we have finished, has a strictly defined filling sequence. And although we have made omissions between the elements, the general pattern of filling, I hope, is clear. Look, in the beginning there is filling of one S. There is no way two S's can be ahead of one S. Then after S comes necessarily two S's, and two P's ahead of two S's cannot be. Then after S, when these sublevels are filled with 2, and on S sublevels maximum only 2, next come P's, and until P electron 6 will not be, this energy level is considered incomplete. But now when we pass to the third period, and sodium, silicon, chlorine and argon are the elements of the third period, their construction begins again already regular 1s2, 2s2, 2p6. These sublevels are finished, and we pass to the third level and fill 3s, and so on until the third level is not filled to 8 electrons, not 18, because d electrons in the third period do not appear. And then we can conclude. So hydrogen and helium is our first. The period, and they fill only one s sublevel. From lithium to neon, this is our second period. They fill S2 and 6 respectively, as much as possible. And the last elements we show are the third period, which is filled in this way, starting again with S until S2 is filled. The others do not appear, and the next N are 6. While in the third period, which is very important, no d electrons have yet appeared, but as a free spare d sublevel it certainly exists. The elements will definitely use this spare sublevel if they want to go into an excited state. This is characteristic of the elements of the third period, of course, because there is a spare d sublevel, but we do not show it, and therefore in the general record, the record D0, 3D0 is not shown, but it is implied that there is such a sublevel. And so today we reviewed with you elements from the 1st to the 18th number. In the next lesson we will find out how the fourth period is filled and what feature the elements will have in this case, which you will definitely need to pay attention to. Goodbye.